In this video we're going to look at the arithmetic of forces. Since forces are vector quantities, column vectors can be used to give an easily manipulated numerical form for the force. So if we consider the force F, which has got a magnitude of 8 newtons and makes an angle of 32 degrees with the positive x direction, then we can create a right-angled triangle whose hypotenuse is the force itself and whose other two sides are parallel to the axes. We can now use simple trigonometry to find the value of x and the value of y. So for x, we've got x divided by 8 must equal cos 32. So x is 8 times cos 32, or 6.784 newtons. Similarly, y divided by 8 is sine 32. So y is 8 times sine 32, which is 4.239 newtons. So the force can be written as the column vector 6.784 in the x direction and 4.239 in the y direction. We say that 8 cos 32 is the x component, or the horizontal component of the force F, and that 8 sine 32 is the y component, or the vertical component of the force F. So now let's consider a force P, which has got magnitude 12 newtons and acts in a direction that makes an angle with the positive x direction of 113 degrees in an anticlockwise direction, as shown in the diagram. Let's express this force as a column vector. Well, again we're going to create a right-angled triangle, but to create the right-angled triangle in this case we're going to have to use an acute angle, which will use that 23 degrees from the y-axis round to the force. So there's my right-angled triangle. So the trigonometry now is going to give me x divided by 12 is the opposite over the hypotenuse. So that is equal to sine 23. So x is 12 times my sine 23, or 4.689 newtons. Y divided by 12 is the adjacent divided by the hypotenuse. So that is cos 23. Which tells me that y is 12 times by cos 23, which is 11.046 newtons. Now we need to be slightly careful on this example because the x component of the force is clearly negative because the force is acting to the left. So the x component of the force is minus 4.689 and the y component of the force, the y component is acting upwards, so the y component of the force is positive, 11.046. If we know a force in its vector form, then it is fairly easy to work out its magnitude and its direction. So let's suppose we've got a force D has got a horizontal component of 6.3 newtons and a vertical component of minus 3.8 newtons, and we wish to find the magnitude and direction of D. So there's a picture of my force D. It's got a horizontal component of 6.3 newtons and it's got a vertical component of minus 3.8 newtons. In other words, a vertical component which is 3.8 newtons in a downwards direction. From our right-angled triangle we can use Pythagoras to find the size of the force. So we've got d squared must equal 6.3 squared plus 3.8 squared. So that gives me d squared is 54.13. Take the square root, I get d is 7.357. So the magnitude of the force is 7.357 newtons. We've got tan theta is the opposite over the adjacent, so that's 3.8 divided by 6.3, and that tells me that theta must be 31.1 degrees. So we can say that the force D has a magnitude of 7.36 newtons and acts at 31.1 degrees below the positive x direction. The resultant of a system of forces is the single force that has the same effect as the system of forces. And it is found by simply finding the sum of the vectors representing the forces. So let's imagine that we've got a sledge being pulled by two forces over an icy pond, as shown in the diagram. So we've got the force P is making it's got magnitude 84 newtons, is making an angle of 28 degrees above the x-axis, and the force Q is making an angle of 40 degrees below the x-axis, and the force Q has got a magnitude of 56 newtons. Then, using our trigonometry again, we can write the forces P and Q as column vectors. So the force P has got an x component, which is 84 cos 28, and a y component of 84 sine 28. So we can write the force P equals 84 cos 28, 84 sine 28. The force Q, looking at the diagram, has clearly got a positive x component, but it's got a negative y component. So the x component of Q is going to be 56 cos 40, but the y component of Q is going to be minus 56 sine 40. So the force Q is the vector 56 cos 40 minus 56 sine 40. The resultant of the two forces is simply the sum of the vectors representing the forces. So the resultant force is P plus Q. So that is 84 cos 28, 84 sine 28, add 56 cos 40 minus 56 sine 40. Adding the x components, 84 cos 28 plus 56 cos 40 gives me 117.07. Adding the two y components, we've got 84 sine 28 plus minus 56 sine 40, just gives me 3.44. So the resultant force is 117.07, 3.44. So 117.07 is the total of the x components of the forces. 117.07 is the x component of the resultant force. 3.44 is the total of the y components of the forces, and it's also the y component of the resultant force. Now that we know the vector form of the resultant force, the techniques that we used in the previous section can be used to find the magnitude and direction of the resultant force. So we simply draw a little picture of the resultant force, which is a force with horizontal component of 117.07 and a vertical component of 3.44. Create our right angled triangle. So first of all, using Pythagoras, we've got r squared equals 117.07 squared plus 3.44 squared. So r must be the square root of 117.07 squared plus 3.44 squared, which gives me 117.1 newtons. So the magnitude of the resultant force is 117.1 newtons. The angle that it makes with the positive x direction is theta, and we've got tan theta is 3.44 divided by 117.07, and that gives me theta equals 1.7 degrees. So the two forces pulling the sledge are equivalent to a single force of magnitude 117.1 newtons, acting in a direction of 1.7 degrees above the positive x direction. So that concludes our look at the arithmetic of forces, and we'll be using some of these results later in the unit.